Hi all, and thank you for joining me. So today we'll talk about writing reliable Ansible playbooks and roles. So about 6 months ago, I received a notification from GitHub. The subject of the email said something along the lines of Sensu-Go collection depends on Ansible Windows, which does not exist. And at that moment, I went, what? And I had a good reason for my reaction. Because when we added Windows support to the Sensu-Go installation role, we did it by the book. So first, we added Windows dependency to the collection requirements and tested things out. So once everything worked, we created new version, uploaded that version to Ansible Galaxy, and then we actually tested the installation. So we made sure that when one installs Sensu-Go Ansible collection, Windows collection also is installed as a dependency. We even built the execution environment just to make sure that our collection works with this new thing that Red Hat introduced a few months ago. So at this point, I was pretty sure that I did not make a mistake and someone else messed up. So I opened an email, start reading it, and when I noticed that there says that Automation Hub, well, let's just say I said a few things that I'm not particularly proud of at that time. So yeah, this is the day I learned that Ansible Windows collection was not certified 6 months ago. And as any other collection maintainer would do, what I did is make Ansible Windows dependency optional, made sure that all tasks that use Windows modules are protected by the when clauses, and made a new release. And then I also learned that Ansible actually loads modules eagerly. So modules are not loaded when used. Modules are actually loaded when Ansible encounters the task that uses a certain module in the playbook. So yeah, I had to make Windows dependency optional for the second time in the last 2 days. So those were the fun days. But yeah, you might be wondering why I'm embarrassing myself in front of you with this story. Well, I think we can all agree that our Sensu-Go installation role was not as robust as it should be. To put it bluntly, I messed up. When I added Windows support to the Sensu-Go installation role, I failed to notice that while most of the collections in the Ansible namespace are indeed certified, the Windows collection was not. And to make matters even worse, this error would only occur in enterprise environments where there is no access to Ansible Galaxy. Okay, so who am I? Who is this person who makes such a mistake? So my name is Tadej. I'm a member of the XLab Steampunk team, and my team specializes in all things automation. We can make Ansible do bare metal provisioning, or on the other side of the spectrum, we can learn it to talk to high-level services such as ServiceNow or Sensu-Go. My role in that team is actually designing and developing Ansible roles, but I also do my best to help maintaining some tools that we use during our daytime. So, for example, Molecule and Ansible Lint are two examples that we often use. But my specialty is actually making a lot, and I mean a lot of mistakes. And in this talk, I'll try to show you some of the things I learned during the last few years while working with Ansible. So yeah, feel free to use this talk to learn things from my mistakes so you don't have to make your own. So during this session, we'll gradually build a sustainable workflow that you can use as a base of your development setup. If you follow the advice in this session, your playbooks should become more reliable and robust, and in the end, you should start trusting your automation more. And with this introduction out of the way, we can actually start working on designing this workflow, and we'll start simple. We'll start with only Ansible and our playbook. So you probably already heard about the run early, run often rule in some other context, but this same rule also holds in the Ansible world. So in practice, this means when I'm writing Ansible playbooks, I usually add a task or two to the playbook and then run Ansible. What this allows me to do is detect exactly when I introduced an error, or this allows me to get rid of those nasty errors such as syntax errors and typos right away. And this is important because Ansible errors can become quite lengthy and dense, so it is really helpful to have only a single error on the screen, resolve it right away, and then move on. So this is why you should really run things often to detect errors early and fix them as soon as possible. When we keep adding tasks to the playbook, these runtimes might start to take a bit longer. And while most people say, well, I'll just stop running Ansible as often, I tend to advocate for a different option. I say, use this as an opportunity to optimize your playbook. So if your playbook is getting really, really long and takes a long time to execute, maybe you should start thinking about splitting it into different roles and then testing those roles separately. Okay, so this is the first thing. First thing, I think it's important to start. And now we can, well, add another Ansible run. So running things again is probably one of the most important things we should do when we develop Ansible playbooks. The reason is, when we run Ansible again, it forces us to think about the desired state of the target host. So the general idea is, first time we run our Ansible playbook establishes the desired state. When we run it again, nothing should change. So the number of changes should be 0. And as I said before, this is extremely important because enforcing the desired state is something that we should really strive for, not executing actions. Why is this important? For example, let's say we have a playbook, we run it, and in the middle of the run, internet dies, as it happens often. If our playbook is enforcing the desired state on the host, we can probably just rerun the same playbook again, and Ansible will sort itself out. If our playbook is executing actions, we will probably need to skip some of the tasks that were already executed, or we risk making yet a bigger mess when we rerun things. So this is why I think it's really important that we run the Ansible twice and try to make our playbooks as little action forming as possible. And well, we just follow what we did now, and we'll add just another Ansible run. And this time we'll spice things up a bit, and we'll actually run Ansible in check mode. And I promise this is the last Ansible run I'll add to the workflow. So what's the idea behind these runs? So what we are actually looking for is just making sure that nothing fails. So when we run Ansible playbook in check mode, nothing should fail. But do note that this only means that if you run Ansible before that. So running check mode on a thing that was not executed at all, well, there is no guarantee what happens. So there things can fail, but running a check mode after the Ansible playbook was executed should not fail. Why should we do this? Well, making sure the check mode works offers a few new opportunities for playbook reuse. So, for example, what this allows us to do is actually detect deviations from the desired state, or in other words, detect configuration drift. So, for example, we can use the same playbook we use to provision our host to also detect configuration changes. And if the modules we use in our playbooks do support diff mode, things become even more powerful because Ansible will actually print the changes that were made. So this is basically a simple mechanism to detect if someone or something is messing with our hosts. Okay, so this, I would say, covers the basic workflow we have, but now we need to focus on one thing that we skipped so far. And we currently ignore that we need a host to actually test our playbooks against. And while we are doing things on a small scale, we have one virtual machine or one container, things are not that bad. But once we start expanding our testing efforts, this manual upkeep of virtual machines or containers can become a time sink, and not a trivial amount of time may start going into managing infrastructure. And luckily for us, this is exactly why Molecule was created. So what Molecule is basically a tool that allows us to list the required targets that we want to test our playbooks with, and then Molecule will take care of creating those instances, running our Ansible playbooks against all of those hosts, and after the testing is done, it will also take care of destroying the hosts so they don't stick around unnecessarily. But we can also use Molecule in interactive sessions. So as we see before, when we are developing things, and we mess things up a little bit during development, we can make host unusable, so we have to destroy and recreate it. And we can use the Molecule for this because Molecule offers commands for destroying all the hosts at once, recreating them, and running different phases that we listed before. So we actually don't have to run all the Ansible commands manually. We can just say Molecule test or Molecule convert, and Molecule will do the right thing for us. Well, Molecule runs in practice look like this. So it's Ansible all the way down. So basically what Molecule does is, Molecule has a concept called driver that basically supplies playbooks for creating and destroying hosts. Those drivers can do things from making sure we create a virtual machine on our local host using Vagrant, or maybe create virtual machines on Amazon, for example, or DigitalOcean. But we can largely ignore this because what is important for us is that we can easily test our playbooks against different versions of things or different operating systems. So for example, it is easy to define Debian, Fedora, Ubuntu virtual machines in Molecule and test that our playbooks still perform as expected on all those platforms. Yes, so although here says testing on multiple ephemeral hosts with ease, I would strongly advise that you start using Molecule as soon as possible. Even if you have only a single host, Molecule will help you spare some time by not making you manage virtual machines manually, and it also makes it trivial to expand your test suite. Okay, so I would say now we have a basic workflow that will make sure our playbooks are functional, are robust, reliable, make what we want them to do. But none of the tools or none of the processes that we see thus far make sure that we are following the best practices Ansible community established over the years. And this is what we'll look at next. And the first thing we'll look at is Ansible Lint. So at its core, Ansible Lint is a collection of rules that all playbooks and roles should follow. So for example, when we run Ansible Lint on our playbooks, we will probably receive some output like that. Some of the rules that are more related to, I would say, syntax, not syntax highlighting, style of the code are not really too important. So it is fine to have a consistent indentation or consistent spacing in your playbooks, but if you are working alone on the playbook, this does not make much of a difference. It is a different thing if you work in a team, but those stylistic warnings can be ignored potentially. But Ansible Lint does output some other warnings that we should never ignore. And one of such examples here is this risky file permission warning. What this warning actually does is it reminds us that whenever we use file or template Ansible module to place some file on a remote host, we should also think about the security implications of our actions. So we need to think what users will have access to the content of that file. So this is why I think it is important to listen to what Ansible Lint says. I'll be the first one to admit that sometimes dealing with Ansible Lint is quite a chore, especially if you want to start using it on an older code base that had a lot of issues. But all things considered, I still think it is worth investing your time in having a clean Ansible Lint run. And if you are a maintainer of a role or an Ansible collection, you already need to do this because Galaxy Import runs Ansible Lint for you, so you have to deal with Ansible Lint errors one way or another. Okay, and this is it. So basically, we covered reliability part of the playbooks, we covered the best practices of the playbooks, and we're done. Everything is nice, right? Well, if you still remember what issue I had at the beginning, so that missing certification on the Windows collection, the sad truth is none of the tools we looked at this far will help us resolve that issue. And this is why my team started developing the scanner tool. The scanner tool does basically the same thing as Ansible Lint, but in a slightly different way. Instead of having a fixed set of rules, one part of scanner continuously analyzes all publicly available Ansible collections and store that information into a database. And the user visible part of the scanner, the one that actually gives us some error messages, analyzes the playbooks and uses the data we stored in the database to generate warnings and to give us some hints on how we can improve our playbooks. So, for example, yes, the first thing that we did is implement the certification check. So right now we know what modules are certified and what modules are not. So this is done deal. But the scanner can also give us some other hints. So for example, here it is telling us that our roles are still using short names. Maybe we should consider using fully qualified collection names. And to make it easier for us, it also tells us where the module name actually redirects when Ansible actually executes it. And this is it. So with this tool, we can really cover a lot of things that can go wrong. So the last thing I want to talk about now is continuous integration, because, well, it's nice to have it, and it's really great to be able to automatically detect errors when they happen. The good news is we don't have to do much to have a high-quality continuous integration here, because our workflow is already CLI-based. All we need to do is provide a configuration for our favorite CI provider, and we're done. The benefits of doing this is if we run our continuous integration process on a daily basis, not only we can detect issues in our collection or in our playbooks, we can also detect changes in the upstream product. So we can either report a bug to the upstream so that the upstream developers can save it, or we need to fix things in our playbook. And this is all I had for today. So what did we learn? The first thing we learned is that I'm a moron and that I do a lot of mistakes. Then we looked at a few tools that can help us make our playbooks reliable, follow standards, and so on and so forth. And we also see that when we have the workflow set up, integrating it into our testing is really easy. But if there is one thing I want you to take from today is this. Please actively search for things that can go wrong or for things that can break. Embrace the tools that yell at you, such as Ansible. Those tools were developed by people who were making mistakes. And this is your opportunity for you to learn from their mistakes. So yeah, this is all I had. I hope you learned something from me. If you have any questions, feel free to ask them in the chat. If you want to talk more, feel free to visit Ansible IRC. I lurk there most of the time. So that's it. Thank you for listening and stay safe.